Hey guys, it's a review for Spiral 4. We're going to start with some domain and range stuff. As a reminder, this is the last time you're going to see this topic. This is probably a pretty important place for you to focus some of your energy. Alright, sketch the graph of a relation with a finite domain. That means it's going to be limited in terms of x. An infinite range, that means it's going to go like off the graph in terms of y. And at least one point where the function value at a specific point is double what the curve is approaching. Wow, I really had to make this that hard, huh? Okay, I'm going to draw this first and then explain why this might work. So the first thing you have to know is that finite means that I've got to have some kind of a stopping point. I'm going to draw a couple asymptotes as a way for us to show that we're stopping in terms of the x direction. And draw a graph that goes between those. So that's my finite domain. It's stopping when it gets to those asymptotes. In fact, my domain for this guy would be from like -4 and up to, that's 3, 6, is that 8? I think that's 8. I don't know. I could be counting wrong. The range in this case, it looks like I'm going from -infinity because I'm way down here. Here, I'll even use a fancy pointer for this. So I'm going to go from -infinity down here all the way up to positive infinity as I keep going. You can totally blame Mr. Butterworth for me figuring out that there are lightsabers as pointers in this. All right. The last piece of this is that a specific point is double what the curve is approaching. That is super confusing. What that means is that if I'm going to zoom way in for this. Oh, that's not zooming. I'm going to go undo and then go to the finger button so I can do this. If I'm approaching this value here from both sides, and let's say this is the point 2, 1, what this is trying to get you to think about is what if, I can't erase what I already did, what if there's a hole in the graph here? So it looks like it's getting, it looks like it's getting there, it looks like it's getting there. And then we have another point that's higher up. So instead of 2, 1, this is supposed to be twice the value. This would be the point 2, 2. Okay. So if you look at this graph as a whole, going piece by piece as far as the information, we've got a finite domain. In other words, the domain stops. We've got an infinite range, so we're going up to infinity or down to infinity. I did it both ways. And then we have a random point where the function is double what the curve is approaching. We end up with something that resembles this. I could also have done for that one, I don't know, that's 1, 2, 3, 4 high. If I had made a point separate but at 8 high, that would make sense for that one too. Do you think it's going to be this hard in the spiral? Probably not. It's probably going to be more application and less theoretical. Second problem. We're looking for a domain is all real numbers and whose range is all numbers between -4 and 4. All right, so first thing I'm going to do is kind of sketch the boundaries I have on my range. Oh, I didn't even see if there were anything. Okay, no other questions for part 1. Okay, so that means I have to stay between these. I cannot go outside of these. I've got to kind of head towards the end, and I've got to go both off the x and off the y. This would be an example of a relation that fulfills both of these pieces of information. We're looking at a domain of all real numbers, so I'm going off both sides of the x-axis, and my range doesn't go above or below -4 or 4. So I'm stuck within these two things. Is this the only way I could draw this? No, it's not. In this case, we have a function, blah, 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 blah. I'm going to undo that. No good, I have to undo a bunch of things. But what if I made my graph like this? Squiggle, 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 and then off. Does it still have a domain that's all real numbers? Yes. Is the range all real numbers between -4 and 4? Yeah, I go through everything in a kind of roundabout way. It doesn't have to be a function. So yes, it can. I was about to say yeah, no. But must it be? Nope. And again, the question that you guys are going to have on your spiral is probably going to be finding the domain of a specific graph or talking about the domain or range in as far as specific values instead of something that's this theoretical. Ooh, function operations involving a graph. Woohoo! I am a little bit sad that you guys don't get to see the colors on your spiral review sheets, but we have them here, so that makes it lots of fun. Looking at function operations, we know that we need to find some of these values based on this graph. Okay, so this graph is f of x. I also have an equation for g. Oh, that's sneaky of me, so I give you a graph and an equation this time. Cool. F of 3 means the height of f at x equals 3. Okay, so x equals 3 is here. This appears to have a height of 0. So f of 3, because that's the point 3 comma 0, is equal to 0. G of -3 means I'm going to plug in -3 to my equation g of x. -3 squared minus 8. -3 squared is 9, times 3 is 27, minus 8 is going to be 19. All right, f minus g of 2. Really important for you to know, this does not mean that we're multiplying f of something and g of something by 2. That was a really common mistake I saw in the last spiral. We've got to go f of 2 minus g of 2. When I plug this in, f of 2, in other words, the height of the graph, f of 2, so we're looking at 1, and then g of 2, I'm going to plug that in here. 3 times 2 squared minus 8. All right. That's going to be 12 minus 8 is 4. So 1 minus 4 is going to be -3. Awesome. F of g of 1. First I've got to find g of 1. And that's equal to 3 times 1 squared minus 8, which is going to be -5. I'm still seeing people trying to multiply here instead of taking this and plugging it in. So f of g of 1 is the same thing as saying f of -5. Okay, here's the rub. If I look at my graph, -5 is over here. My graph doesn't exist. So f of -5 does not exist. I'm going to use D and E because I don't have any room. For those of you that go on to take calculus next year, you'll also use D and E a lot for things that do not exist. Last piece, all values of k such that f of k equals 0.5. Oh boy, that's different. So we might look at the first thing is, okay, this is the height of the graph. So height of f at x equals k is 0.5. And that kind of gives it away a little bit. So 0.5 is here, and it looks like I've got two places that have a height of 0.5. It looks like k could be, and that's, I don't know, 1.5-ish. And k could also be 2.5-ish. You thought we were done, but we're continuing. I'm going to sketch a graph. Ooh, that's exciting. And it's the same thing that we were using the function section. How crazy is that? So we're going to sketch this graph. I realize one may have gone a little bit crazy there. I'm going to use my transformation notation, and I'm going to take a look at this. I'm going to go point by point to see where each of these points are going to end up. All right, so that's -3, -3. We've got -1, -1. We've got 0, -1. We've got 2, 1. And we've got 3, 0. Okay. I'm going to start with 2 times f of x minus 1 plus 2 is equal to my new function. Okay. I
I know that I'm going to take the inside here, and I'm going to set that equal to each x value. So let's start with negative 3, negative 3. I'm going to take that first negative 3, and that's equal to x minus 1. Therefore, my new x value is going to be negative 2. Okay. For the y value, I'm having two things happening. I'm going to multiply by 2 for the number out front, and then I'm going to add 2. So if I start at negative 3, I'm going to multiply that by 2 for the number out front, and then I'm going to add 2. 2 times negative 3 is going to be negative 6, plus 2 is negative 4, and that's my first y value. So negative 3 comma 3 is going to become the point, negative 2 comma negative 4. I'll change colors. Okay, I'm going to use some of the space on the next page to continue this. So negative 1, negative 1. First thing, x minus 1 is equal to negative 1. That means that x is equal to 0. And then I'm going to multiply the other negative 1 times 2 and then add 2. And that's going to give me 0. Cool. So my second point is going to become 0, 0. And that's that first segment. Okay. It actually might be a little bit more effective to use red to show that that's replacing the red segment. My next point is going to be 0, negative 1. 0 equals x minus 1. That means that x equals 1. And then I'm going to take negative 1 times 2 plus 2, and I get 0 as an answer. So we're looking at the point 1 comma 0. And I'm going to use my blue because, well, that's the blue section. Next up, we're looking at the point 2 comma 1. And I'm going to do x minus 1 is equal to 2. In other words, x equals 3. And then y times 2 plus 2 should be 4. That's the point 3 comma 4. Okay. 3 comma 4 is up here. And then finally, I'm going to look at the point 3 comma 0. And 3 comma 0, I'm going to do the same thing. X minus 1 is equal to 3. That means that x equals 4. And then I've got 0 times 2 plus 2 is 2. So 4 comma 2. So keeping those in line with the colors, the description here might be all points moved right 1. Then we multiplied y by 2, and then we went up 2. Cool. All right, m of negative 2 and m of 4. There are a couple different ways that I could do this. The first way that I might be able to do this is to take a look at my graph. M of negative 2, so the drawn-in graph is m. Negative 2, m has a height of negative 4. M of negative 2 is negative 4. M of 4, I'm going to find the height there. M of 4 is 2. As an alternative, let's say you didn't know how to graph this thing. I could just plug that in. So m of negative 2, I could write as 2 f of negative 2 minus 1, and then plus 2. Okay? In doing that, sorry for running over the next lines, so in other words, that's 2f of negative 3 plus 2. F of negative 3, okay, that's going to be negative 3. So 2 times negative 3 plus 2. 2 times negative 3 is negative 6, plus 2 is negative 4. You can plug these in instead of graphing them if you have trouble graphing them. You've got to solve a pair of right triangles. I'm going to start off by using some trig. Okay, I know if I've got this angle, we're looking for the other angle, so that's 90. So we're looking at 180 in total. I've got 90 left to use. Minus 33 is going to be 57 degrees. Okay, to find x, I might use sine of 33, and that's equal to 21 over x. I'm going to multiply both sides by x, and I end up with x sine 33 is equal to 21. And if I divide both sides by sine 33, I end up with x is equal to 21 over sine 33, which is going to end up somewhere around 42. Okay, looking at my other value, I could use the Pythagorean theorem for that. It means I might as well find that trig value. So we're looking at 21 divided by sine 33. That's going to be 38.55. So if I want to use Pythagorean theorem, 21 squared, I'm going to call that z, because I like z, plus z squared is equal to 38.55 squared. So 38.55 squared, 1486, minus 21 squared, 1045. Z squared equals 1045.1025. Do some square rooting. I get z is 32.32. I've got x, I've got z, I've got all the angles. I have solved the triangle. The other one, I'm looking at 18 and 9. Cool. I don't know this angle. I don't know this other side. I might start for the other side. I'm going to call this W. So I've got W squared plus 9 squared is equal to 18 squared. And if I do that out, I've got W squared is equal to 324 minus 81. 324 minus 81 is going to be 243. 243. Square root both sides. And I get W is the square root of 243, which you might recognize as 3 times 81, which is kind of neat, because 3 times 81, if I square root that, I'm going to go up here, sorry, the square root of 3 multiplied by 9. 9 square roots of 3. If you didn't feel that creative, that's fine. You could leave that as either the square root of 243, or if you really wanted to, 15.58. Okay, let's set this up. So we're looking for, I don't know, I know these two are already here, so that's opposite hypotenuse compared to this question mark. Sine question mark is equal to 9 over 18, which is a half. Hey, that looks kind of familiar to some angles we've been working with the past few days. But that's okay. So to get an angle from a ratio, I have to use the inverse sine. This is something that we're still having trouble with that we need to fix. So sine inverse of a half is going to be 30 degrees. What? How crazy is that? This is the 30, 60, 90 right triangle. Because if that's 30, that's got to be 60. We've got 4A. The sun is at an angle of elevation. All right, here's my sun. Angle of elevation, that's going to be here, 58 degrees. a tree, there's my tree, cast a shadow. Okay, so shadow is going to be down here, 20 meters long. How tall is the tree? So shadow is the length in the bottom. The tree is what I don't know. That's opposite and adjacent. So we're looking at tangent. So tangent of 58 is equal to x over 20. X is equal to 20 multiplied by tangent of 58. And you can call it done there. Or if you want, you can do it out. 20 times tangent of 58. X equals 32. And it's pretty close to 32 even. So 32 feet tall is the tree. Person starts out 17 miles from the base of a tall mountain. Ooh, that's exciting. There's my mountain. It's really tall because it's just a peak. All right, 17 miles. And they look up at a 4-degree angle of elevation. All right, when they move 12 miles closer, so now if they're 12 miles closer, that means they're 5 miles away. What is their new angle of elevation? Oh, this is cool. This is like a 2-part problem. How awesome is that? So if I were to do this, I might try to do the purple triangle first. And then, once I have the purple triangle, I might take a look at this other guy. Because that's going to be the same height in both cases. How amazing is that? So first things first. What I could do is treat this as a tangent problem. So we've got tangent of 4 is equal to x over 17. 17 tangent of 4 is equal to x. So 17 tangent 4, and that's going to be 1.18. That seems really small. Oh, wait, we're in miles. That's fine. So 1.189 miles. Okay, that's the same one. And now I'm trying to find that angle. That looks like a tangent again. So tangent of question mark is equal to 1.189 over 5. That means that tangent inverse of 1.189 over 5 is equal to whatever that question mark is. Tangent inverse 1.189 divided by 5. And I get 13.37 degrees. All right, one last doobie. This is law of cosines. I know I'm solving for an angle. I'm using A. So I'll probably use my A setup. A squared is equal to B squared plus C squared minus 2BC cosine of A. Plugging things in. A, that's C, and that's B. 4 squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times cosine of A. 16 is equal to 100 plus 64 minus 160 cosine A. Here's where the most common thing to go wrong is. You cannot combine this with the numbers. That's got to stay separate. That's 164 out front. Get a minus 164 to both sides. Negative 148 is equal to negative 160. Cosine of A. Now I'm going to divide by 160 negative to get rid of that. And that's 0.925 is equal to cosine A. I know I have to use inverse cosine to get A. So inverse cosine of 0.925, and that's equal to 22.33 degrees. We're almost there, guys. One section left. One section left. Sketching in standard position. Negative means I'm going clockwise. 350 means almost all the way around. Two terminal angles, I might add 360, and I get 10 degrees. I might add another 360, and I get 370 degrees. Those two are both coterminal to that angle. 660, whew. So we're going counterclockwise. There's 360. And if I keep going around, that's going to be 450 because I'm plus 90, plus another 90 is 540. Then plus another 90 is 630. I'm going to be somewhere over here. Another way for us to kind of make some sense of that, if I subtract 360, I end up at 300, which is a little bit easier to see that we're down here. We also end up finding one of our coterminal angles very quickly. If I wanted to, I could subtract another 360 from that, and I end up at negative 60. That's both coterminal angles. There are an infinite number of answers that you could have used. Find the measure of each angle and then state the reference angle. So if I start here and I'm going this way 170 degrees, that means that my angle is probably going to be negative 170 degrees because that's what negative angles do. My reference angle is how much is left, and there are only 10 degrees left to get to 180. So my reference angle would be 10 degrees. Convert from degrees to radians. I tend to think about this in terms of, I know in a circle there's 2 pi, and in a circle there's 360. So if I make this into some kind of a fraction, I can reduce it, and that'll give me the radians. Negative 150 times 2 is going to be negative 300 over 360 times pi. Tens can cancel out. Negative 30 over 36 is going to end up being negative 5/6, and then there's a pi. Okay, converting from radians to degrees, I'm going the opposite way, so I know I'm going to be dividing by 2 pi and multiplying by 360. My pi's can cancel out before I do any math. I like cross-canceling. That's helpful. 360 divided by 6 is going to be 60. And then 60 divided by 2 is going to be 30. So 11 times 30 is going to be 330 degrees. If you're using a calculator for this part, you need to be careful to leave your pi's off and don't put them on until the end. If I get some really ugly decimal for this, you're not getting credit. You need to show me radians in terms of pi.